Hello everyone and welcome to a live stream. So in the last live stream, we have coded a market analysis app for various symbols, and so today let's just have a quick summary what this app is able to do. So this market analysis app has an input component on BTCSD, and when you submit the data, it will analyze for the past 10 years how each month has been profitable or losing, right? So what you can see here on this chart is that, for example, Bitcoin has a tendency to rise in February, right? So for example, all of these little boxes here are the respective months for the respective year, and here we see that there is a clear trend that February is potentially a good investment opportunity on Bitcoin. Another one that's coming up is October, and I've been talking about it for multiple streams already. So October is something that we are planning, we were planning to go long, and so yeah. So we've also made some other analysis. One of my viewers asked me, for example, to perform some analysis on XUSD, and we see that XUSD has a tendency to rise in December and January. So maybe in December we'll have a look at XUSD if we might have any opportunities to trade it here. And yeah, so this is the app. By the way, I've mentioned that I'm going to, create, to host this app publicly so everyone can access it. So this is currently in progress. And I was thinking that, recently my videos where I've been coding the trading apps live, such as this one, have been performing very well. So I've decided, to maybe create a collection of trading applications that we could put into a single, trading web app that will host many of these applications, and this is the idea behind that. So for today, I've decided to work on another app, and this app is basically the Monte Carlo simulation. And what it does is basically it uses some random statistics and probabilities, and it is simulating a trading curve. So in trading, you know that the outcome of each individual trade is pretty much random or based on probability. So not every trade has 100% win rate, and we're going to simulate that based on some statistical methodologies. We're going to have drawdowns, periods of good trades, periods of bad trades, and we're also going to implement something called fee and commission simulation. We also can simulate which strategies may perform in high commission or low commission markets. So all of that we're going to do today, and hopefully by the end of today's stream we'll have an app that looks something like this. But we are going to add some of our touch into that, where we can also implement some of our own data for evaluation. All right, so maybe a quick update on the profits, right? So as you can see, MTD profit, we've made a loss yesterday, and as a result, our month is 25 euro in loss. So that is very unfortunate, but the month is almost over, and our Bitcoin setup is coming up next month. So hopefully, we'll have a better month. And of course, the month's not over yet, so we still have this week to go, and there's a high chance that we might end up in profit. So let's hope for that to happen. And yeah, so this is everything regarding the update. Let's get coding. All right, so we are in our IDE called ATJ Algo Training Edu, which is our, which is a project hosted on our GitHub page. So if you're new to the channel, you can go to my website and you'll find the link to all the source code there, right? So all you have to do is go to atjtraders.com /join or just atj.com, and here you will find a link to my GitHub page, and so you can see all the past projects and live streams where I'm sharing the code with you guys. So feel free to check that out if you're interested. And so what I'm going to code today will be found on my GitHub page later. So here we have the stream, that I was streaming on Monday with the market analysis dashboard. You can find it here. And for today, I'm going to create a new directory. So for today, we're creating a stream directory 2024-09, and today is September 26th, right? So today, this is today's directory. And today's app we're going to code is the Monte Carlo simulation, right? So Monte Carlo simulation, by the way, maybe a few words. So as you know, it's basically a simulation of, some statistical probabilities. It is widely used, for example, in gambling as well. So for example, if you're a poker or blackjack player, you also work with probabilities, and you can apply this concept on trading as well, because, not every trade is, 100% success rate. So for example, if you have 50% success rate, so basically the trade is a coin flip, and you have a certain reward to risk ratio, we are going to simulate the expected profit, expected drawdowns, and things you should expect when you work with the simulator. It is very useful, to plan your risk management accordingly. And when you are, for example, over leveraged, you will find this application. So if you are a trader, right, who wants to make big money, but on the other hand, you are not aware how big the drawdowns might be, these drawdowns are potentially, yeah, bad for you. So let's create this app, and I'm just going to call this app.py. And the framework we're going to use for this application is Flask. I'm sorry, Flask and Dash as usual. So Dash is analytical web framework in Python, and we're going to use Dash today. So from Dash, import Dash, right? So again, app is equal to dash name. Here we are creating or instantiating our application, and we will now set a very basic layout. So app.layout. And if you worked with HTML, so we can import HTML from Dash. We are able to create HTML components. So if we, for example, specify html.div, this will create a div component in our application, and I can also create an h1 component, which is basically our heading. So HTML h1 is a Monte Carlo simulation, right? App. So now that we have our basic layout done, we can run this app to see if it works. So if name is equal to main, right? We are just adding it into our if block in Python. We will just, do app.run, and then as a result, our application will be running. So we can close our previous application, and let's run this one. So now our app is running, and here we have our web app with this heading, right? Let's add some CSS, right? So this app also looks, somewhat nice. And for that, I will use Bootstrap. And there is a framework in Python where we can import Bootstrap. So import dash Bootstrap components as DBC. And again, we can specify the CSS using external style sheets. So we're not here, but when we create our Dash application, and then we have various themes, and my favorite one is Darkly, right? So we're using the Darkly theme. So we can run this again, and now we have our Monte Carlo simulation app, here in dark mode. All right, let's just add some quick margins. So what we can do here now is we can just copy some settings from a previous app, because the previous app is using the same CSS components, and I'm just going to add some margins on the left, right, and the upper edge. So we can add the style here. If you refresh this, right, and we see this app here, this is the old one, and now we refresh the app. Now we see that we have added margins, and it's a little bit more, nicer. All right, so first thing, what we will need is some input components, right? So we will need to work with some components such as, win rate, reward to risk, number of trades, number of simulations, and then maybe implementing commissions with the broker, right? So we can see, how the strategy is performing. So I'm just going to add some static variables, right? So before we are doing some inputs, some dynamic inputs that we can add to the app, let's just, create a static dashboard with some default parameters. And so for Monte Carlo simulation, the things that we will need is basically the win rate of your strategy, right? So the win rate is a value between 0 and 1. 1 means that all your trades are profitable. 0 means that none of your trades are profitable. So let's create a strategy that's like a 50% win rate, right? So 0.5. And so this means that every second trade should be a winner. And then there is a metric. This is a very common metric used in trading, which is called reward to risk. And reward to risk is basically how much money you're gaining compared to how much money you are losing, right? So if, for example, your reward to risk is 2 to 1, and of course in Python you can't use, the double dots. So we simply can divide like this. So this means whenever you win, right? Let's say you flip a coin. Whenever you win 2, but whenever you lose 1, right? So this is what it means. And so 2 divided by 1 is still 2, but we can leave it as this, so we can see that every time we win it's 2, every time we lose is 1. And this, by the way, is a very good metric. In my opinion, it's quite not realistic to have it all the time like that, but just for presentation purposes, let's leave reward to risk to 1 and win rate to 0.5. All right, so other things that we'll need for strategy is we need to simulate the curves, right? And we need to simulate how many trades the strategy is performing. So what we have is we need to simulate, the simulation for a certain number of trades. And let's say this strategy, for every simulation, we are going to perform 100 trades. And then what we're going to do is we're going to simulate number of lines. So how many times the simulation should be running. So num lines is equal to, let's say 10 lines, right? So now let's try to run the simulation. And of course, we will need some random number generator, right? Because the outcome is random. So we are going to import random. And now what we're going to do is we have to generate, let's generate some results. And I'm going to check, the documentation on random, right? Because I haven't worked with random for some time. But we can just, check the, online documentation and see how it works. So random has various various methods here, and the one I'm going to use is rand int, I believe. So or here actually what you can see returns a random float number between 0 and 1. This is actually better because we already have the win rate specified. So, the win rate is between 0 and 1, and if the win rate is 50%, so if the random returns below 50, it's going to be a loss, and if it's above 50, it's going to, make a profit, or vice versa. Let me just try to implement it in code. So I'm just going to print random dot random, right? And I think based on documentation, it should return a random float number between 0 and 1. And we do have that here. Great. So what we're going to do now is we need to create an iteration, right? So you know what? For the first iteration, let's just iterate for the first line. So for I in range, right? So we're looping through 100 trades. We want to generate 100 random numbers, right? So here we can print I, which is the the index of our trade, and then we do random here, right? So here we see that we have generated 100 random numbers, right? And so now what we can do is for the simulation, when we want to check, if, for example, the random value is greater than our win rate, it's a win, and so on and so on. So I'm just going to change a few things. So I'm just going to save this into a variable. So this is our random number. And so if our random number, let's say actually it's less than our win rate, we are going to, have a win, right? We are going, the trade is a winner. Otherwise, we print lose, right? All right, so here we see that this number is less than the win rate, so it's win, 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 lose, lose, right? Let's just, confirm that it works. So let's say we have a win rate of 90%, right? So this means that 9 out of 10 trades should be a winner. So the chance that our rand end is gonna end up in 90% of that, right? Because if the random number generated is less than 0.9, then this should generate a winner. So we win, 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 and then occasionally 1 every 10 times we should find a lose, right? So here we have a lose, for example. So we see another lose here because it's above 0.9. So we see that now the result is working. And now what we can do is we can actually compute the expected, result, right? So what we can do is we can create another variable called risk per trade, and we can specify in US dollars. So on every trade, let's say we are risking 100 US dollars, right? So whenever we win, how much do we win? So our reward to risk is 2 to 1. And so that means that when we make 2 to 1, we make $200 because 100 times 2 is 200. So our profit is equal to risk per trade times reward to risk, right? And here, in case we lose, our risk per trade is equal to risk per trade times one. It's actually just a risk per trade, right? So we are just risking this amount, and we are winning this amount. And of course, we have to multiply it by -1 because this is a loss. So now we will create a profit list, right? So this will be an empty list, and whenever we have some value, some outcome here, we are going to append that. So profit list dot append profit. So after the end of this solution, after the end of the simulation, we are going to append that, and we are going to print the profit list, right? So we are going to keep it outside of this loop. So now we run this, stop and rerun. And here I see an issue, and it is that I'm actually, resetting the empty list inside the loop. So what I'm supposed to do is I have to initialize it, before the loop. And let's try again. And here we see, that we have our list of trades. So let me just reset this value to 0.5. And I believe I don't need to, print the random number here anymore. So instead, what I'm going to do is I'm going to print, the values here. So here I'm going to print I, which is the ID of the trade, right? So this is I. And then I'm just going to print a profit so we can see the result for each trade. And here we see, so for example, trade number 52 has won 200. Trade number 53 has lost minus 100. and here's a profit list. So this is the list here, and I believe what we can do now is we can convert it to a pandas data frame and then work with this, and then we can use that to simulate the curves. So basically, what we need now is we have simulated the trades for each individual, for a single line or simulation, and we also want multiple simulations. So first, what I'm going to do is I'm going to save inside that list not just the profits, but the values, right? So we are going to save the ID of the trade, which is our I or index, right? So this is the index of the trade. Next thing we're going to save is the profit, right? So the profit of this trade is our profit, of course without this. And then before we start, saying that index, we also want to check the iteration. So the iteration basically represents the simulation, or actually let me just call it simulation so it's more clear. So the simulation is basically 1 in this case. So next thing I'm going to do is I'm going to create another loop, right? Because this is just generating trades for a single simulation, and num lines. Let me just change it to num simulations, right? So it's more obvious what we're doing. So number of simulations 10. So here we do for let's go for simulation in range num simulations, right? We have this value here, and we can save. So now let me try to run this again, and now it's actually performing a very long loop. So it's looping 10 times and then 100 times. So in total, we should have like a lot of values here. So this is simulation number 0 with index 0 and profits and so on. So here, what we have here is just passing the profit list here. And let us print the F and see what that does, right? So let's reset it. Great. And so what we see here now is that we have, the idea of simulation, we have the index and the profit. So the last thing that we're going to do is we're going to visualize that so we can actually see how these things perform, right? So what I can do is I can also import Plotly. So import plotly.express as px. And I'm just going to create a very simple line chart. So our figure is equal to px.line. And we just need to provide df, with the index, which is the index of trade, and y in profit. And I'm also going to create a color separation. So we are separating it by color based on the simulation number here. And for those of you who are not following along, let me just show you what this does by calling fig.show, and that will generate a chart. All right, so now we've generated a chart, and I see, where I made mistakes. So we see, that the trades are oscillating profits between -100 and 200. But the thing is that I should have also computed the cumulative profit, right? Because this is the profit, individual profit. But what we're supposed to do is compute the cumulative profit of each simulation. So df cumulative profit. So I'm creating this column here, is equal to the profit, and then we just group by the simulation, and we use the cumulative sum, right? So this is how you add 200 plus 200 minus 100 minus 100 and so on. So this is what we're doing right now. And let's see. Oh, of course, this part here should be at the end. Okay. And now that we have successfully computed a column, I'm supposed to visualize this column here. All right, so now we see, the result of this equity simulator. So we see that most of these strategies are winning, So again, we have a win rate of 0.5. We have a reward of risk of 2 to 1, and we have 100 trades for each iteration. So what we have here is that most of these things that a strategy that has the same statistical probability can have very different results at the end, right? So for example, this strategy, simulation number 8, has generated 2,600 US dollars of profit, whereas this one has created 8,000. And this is actually very important, to keep note of, is that even though your strategy might be underperforming or overperforming, it is all part of, some, probability, and you shouldn't be discouraged to see, that in some cases you might be in a loss or a drawdown. And I think in real life scenarios, the edge is much smaller, right? So when we look at the reward to risk, we can always, yeah, I wish I had 2 to 1 reward to risk. I wish I had 50% win rate. But this is something that you can't influence, right? It is something that is given by the strategy you're trading, and every strategy, that is backtested has these certain, parameters. So let's say that instead of, 2 to 1 reward to risk, we only have, uh, an edge of 0.4, right? Or even let's say like 3.7. So in this case, this strategy has a very slight edge, and with a very slight edge, the results are a little bit more volatile, right? So we see that overall the curves are in profit. Maybe what we can do is we can create like an average of all of these, curves. We can try doing that, uh, which I actually will. But what I want to mention is that some strategies are losing, some are in a big drawdown, but overall, these curves show a profitable tendency, right? So in real life trading, you should be aware that, there are a lot of, deviations, and this is what this app is supposed to show. So you should also look at the drawdowns, and so on and so on. Okay, so now that we have, a static page, we want to create a dynamic page. And to create a dynamic page, we need to, first put this into our layout, in our trading app layout. So instead of showing the fig here, maybe what we can start with is we can display it in a graph. So we can call dcc.graph, and I think I still need to import dcc from dash. DCC is a set of components, where you can, for example, show plotly charts. And here I'm just going to pass in the parameter figure is equal to fig. So let me run this again. And now let's run this app. And what you can see here is, yeah, we can now see the chart here with all the trades visualized. So this is great. Let's create some inputs in this application. So here I will create same input components as here. So these things will be dynamically put into our application. And so what we need to do is in the layout section, we need to create our input components, right? So here, let's do what is it? dbc.label, right? And label, we're just going to label our component. So first thing is risk per trade, right? So here we are going to specify risk per trade, and then we are going to use dbc input and with the ID risk per trade. Then we are going to create another label for the other variables that we have. And here in this label, we are going to do the win rate. And then we are also going to create an input with the ID win rate. Okay, so then we need the reward to risk, the RRR. So dbc.label is our reward to risk. And you see the pattern here, right? So we can actually copy the remaining two, and the remaining two are number of trades and number of simulations. Let me just shorten that. So I prefer just using num, so we save a bit of space. And here we just do num trades, and here we do num simulations. Okay, so let's just refresh the app and see what it looks like. So here we have this here, and yeah, it seems to be working great. So we have risk per trade, win rate, reward to risk, number of trades, and number of simulations. So now let me just create some space here. What I can do is quick separate, so html.hr to separate the inputs and the outputting page. And let's run this again. All right, so here we have the submit button here. I believe that, maybe we can put the submit on the right side because that's commonly used. Shimo just comment, hey TJ, good content. When I translate Pine script strategy in Python, I never get the same results values. Is there a way to do this? Can you produce a direct Pine to Python tool? I didn't see one. I don't have any experience with Pine script. I believe you were talking about TradingView, but maybe if you can summarize the strategy, we can maybe just work in pure Python because that's what I specialize in. And yeah, so sorry, can't probably help too much with that. But yeah, thank you for a comment, and I'm very glad that you like the content. So the submit button, we wanted to put it to the right side. So for a submit button, to put it on the right side, I believe we need to use style is equal to, and I think it's text align right. I'm not really good at CSS. This is something that I always wish I knew little bit more, but I try to be more practical. So yeah, but it's always not a bad thing just to look at online. So align button right. I think many of us who worked with CSS, and web development, were using that. So they use style float right. Let me try that. Stack Overflow will always save you when you don't know, at least with these simple things. Okay, so thank you, Stack Overflow. Let's refresh this, and it actually works, which is amazing. What we see here is that the separator here is actually cutting through our button. So maybe what we should try doing is let's add a BR here. Right, and here we have the separator. Or theoretically, we actually even don't need a separator, in my opinion. But it creates some margin, above the button. So you know what? Let's leave it as this, like this, right? And we can improve the design later. Design can always be improved, but here we have the risk per trade, right? So we can, for example, specify 1,000. We can here specify the win rate, which is 0.5, for example. Reward to risk is 2 to 1. So in this case, we just specify 2. Number of trades by default is 100, and number of simulations is 10, right? One thing that I could do is I can specify some default values for our test run. So our value for number of trades, let's set it to 100, and our value for number of simulations is set 10, right? And you can always edit it, in the web application. So the only things that are dynamic are risk per trade, win rate, RRR. So here, just to show how it works, so here I can also specify value, risk per trade, let's say $100. The win rate value is equal to 0.5, and the RRR value is equal to 2. And the comma is missing, and let's run this thing. Okay, so now we have our default value set, so everything is great, and now we just need the submit button to work. So whenever we click on submit, we want to generate a new chart. Okay, so what we'll need is we have to create a callback, right? So a callback is basically just some logic. Whenever I do something on the page, it will update some other components on the page. And to use callbacks, I need to use app.callback. And I will need to create some output components. Instead of having a static figure, right, like this is a graph, I will have an HTML div that will listen to these inputs and then generate the charts accordingly. So ID is equal to, let's just call it page content for now. Okay, so page content, we will need to import some other components. So next is output, input, and state. And so in this callback function, our output is the page content, right? So our page content is our output, and here we have the appropriate children. So the children of this component are our output, and the inputs are the risk per trade, win rate, reward risk, and so on. So the first input that we're listening to is the submit button, and we're checking if it was clicked. And then we are using the state properties. So the state not triggering the callback, but whenever the callback is triggered, we will check the data. She asks, can you develop an application that can add a strategies only via web UI? I think it's a good idea and can relieve you and us. Yeah, that is definitely a great idea. This is, of course, a little bit of a larger project, right, where you can do strategies. But maybe if we start with very simple indicators, such as moving averages, Bollinger Bands, high-low super resistances, I think that this could be viable. So my idea, or maybe because you asked my idea what to do, within the next like 2 or 3 months, is to develop very simple applications. So for example, the one I'm doing right now, and once I have a collection of simple calculators and apps, maybe we can dive into more sophisticated projects that you can also benefit from. So yeah, thank you for your feedback, and I'd be very happy to work on such a project. Okay, so here we have risk per trade and value. Then, and here this is where the autocomplete is really handy. So we can use the win rate, RRR, number of trades, and number of simulations. So as you can see, this app is really great in auto-completing in some cases. So I actually do recommend PyCharm when it comes to this. And I don't know how other IDEs are performing, but I love this. So define serve page. And here we just need to, add the inputs here, right? The button, risk per trade, and so on. So here we just add end clicks, then we do risk per trade, and again, auto completion is really handy here. So I'm going to print the values here, and let me rerun this app and see if this app is actually working. All right, so now I refresh this. I press on the submit button. And let's see if we have any update on our terminal. And as you can see, we have printed our end clicks, risk per trade, win rate, RR, num trades, and num simulations. So first thing regarding end clicks. So if the button was not clicked, so if end clicks is none, we just return empty, right? An empty div, or we can just empty return nothing. This is fine. So if the button has been clicked, then we want to perform the simulation with these values here. And the good thing is that we've actually done that already, right? Because this part here, we can just, and these things we can delete, right? Because they are now specified in our web app. Right. Thank you, Shimo, for nice comments. Glad to have some appreciation. Uh, and yeah, so yeah, we'll keep working on that. Okay, so here are our simulations. Here is our data frame. Here is end clicks. Um, this part here actually, let's put it up here just to check if we have everything we need. And here we are generating our, our simulation. So our figure is what we want to return. So we return dcc.graph with figure is equal to fig, right? So this is the return of this callback. So let's try to run this, right? So now we have the page empty. We press submit. Now we see it's updating, and now we see the charts has been generated, right? So if you, for example, reduce the number of trades to 50 and we press submit, right, it's going to generate another chart, and hopefully it's yeah, it generated a new chart, but unfortunately we were not able to see that. So let's do like number of trades is 50, and hopefully it will create some output. And I believe that actually I'm having an issue with, yeah, it's actually returning some errors. And let me see why that is. String object cannot be interpreted as an integer. Okay, that makes sense. So it assumes that the values here are strings. So what I'm going to do is I'm going to convert this into numbers. So I think this is the first thing that we should do. So risk per trade is equal to, and we convert it to float, right? Win rate, same thing. And here autocomplete again is very useful. And number of trades and our summation is an integer. Okay, let's try rerun this. And what I was thinking is instead of using HTML div, we can use dcc.loading, because what dcc loading does is it creates like a loading icon, and with this loading icon, see that the app is loading something new. I think that is very useful. So for example, if I press submit, what you see here is a loading icon, and now the data is being generated. And let's try to rerun the app. Let's say number of trades is 50, and let's submit that, and here we see that we are generating chart with 50 trades. We can increase number of simulations to 30, so we submit that, and now we have 30 different simulations. So I guess, yeah, this app is done. So as I said, we can compute other things such as the averages, drawdowns, maybe not use static risk per trade, but more dynamic ones. But overall, this is the general concept of this app. So I will post this app online so you guys can check it out for yourselves. And if you're interested in, I'm going to share the link on my next live stream where you can try out this app. So yeah, so guys, if you have any questions, let me know. And I believe that this is it for today's live stream. I had a lot of fun coding this Monte Carlo simulation app, and I'm going to come back with more applications. So again, my plan is to open a Bitcoin trade in October, maybe find some other trading opportunities, and we'll be focusing a bit more on trading applications in general. So you guys can also benefit more from me coding in front of you if you are not that proficient in programming. So again, thanks for watching, and see you guys next time, probably on